Welcome. We are going to start discussing our next unit study, functions, and specifically domain and range, and how they apply to functions. So let's begin here with a little discussion on domain. Let's get this pen thinner here. It says it's thin already. Domain and range. Now, the simplest way to explain domain and range is domain is your set of x values, and range is your set of y values. Now, that's the basic information you guys have been taught since you've learned anything about domain and range. But you need to be careful because now in courses like this, we're starting to talk about things not in terms of x and y, but maybe like an L and a W, or an R and an H. Right, so set of x values isn't very specific enough. So what that really means is our independent variable. And our independent variable is always our horizontal axis. And then our range would be our dependent variables. Dependent, which is our vertical axis. Okay, so that's really the true definition of domain, your independent variables, and range is your dependent variables. Okay, so let's just look at a brief example here. If I draw a sketch of a continuous function, which we'll talk about the meaning of that, right? This one I just drew it as is, and I have my horizontal axis, call it what you want. We'll call it x and y, the typical thing. Since I have arrows that show this going on forever in a left and downward direction, but more importantly for domain, in the left direction and the right direction, my domain is all real numbers. Okay, and that can be written in either of these two ways right here. Okay, you could also write it a third way here. There's probably more ways. Okay, as far as our range goes, so we're looking vertically now, up and down the graph. This goes down forever and up forever. So again, all real numbers. Negative infinity to infinity. Again, the exact same options for how to write it. All right, interval notation, inequality notation, or just the symbolism for it. But these are kind of boring graphs. We know the domain and range of them. This is also a function. We'll talk about that a little bit more here as well. Let's look at something a little more, maybe not interesting, but a little different. And let's just look at a graph. This is actually called the greatest integer function. It looks like this. Not a function you need to be responsible for, but the point is we should be able to look at any graph and determine the domain and range of that graph. So if I look at the greatest integer function, it's going to, let me get a different color here, it's going to look like this. I put 0 in. So it's going to be what's called a step function. Okay, so it looks like a series of steps, and it continues on in both directions, like this. That's 1's over here, 2, 3, 4. This is 1, 2, 3, 4. Okay, so here's our step function. So I'm looking at this in terms, and of course it goes on forever and ever in both directions. So if I'm looking at my domain, I'm thinking, what are my input values? Just my x values. Well, I have everything covered between 0 and 1, everything between 1 and 2, everything between 2 and 3. I have everything covered, so it's all real numbers. But now my range, you notice with my range, I have all these gaps in here, right? There's nothing in there. There is nothing in here. There's nothing in here, right? So I'm missing all the values between 2 and 3, between 1 and 2, between 0 and 1, everything between 3 and 4. So my range is simply 0, 1, 2, 3, dot, 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 and that, of course, is in both directions. Okay, so you can say that's your set of integers. Here's our symbol for integers. Or you can just simply write the set of integers. Again, it's a little extreme case, but the point is you should be able to say, oh, well, it only covers the values 0, 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5, okay, for the range of the function. Notice I used the word function. This is still a function because it passes the vertical line. I can draw a vertical line anywhere I want. Now you might say, no, you're crazy. It fails right here. But it doesn't, because I have a closed circle at one point and an open circle at another point. So it does pass the vertical line test to determine if it is a function. It sure does. Let's look at another example for domain and range. Let's say I give you the points 2, 3, 3, 5, 7, 6, 12, -4, -15, 6. Okay, your domain is just your inputs. So that would be all the x values. 2, 3, 7, 12, -15. Or if you don't like x values, you can say all of your first coordinates. And your range is simply your outputs. 3, 5, 6, -4. And 6 again, right? But I don't need to list it again because it's the same thing. Now, is that a function? Does it pass the vertical line test? Well, maybe not, because we have 2 6's here. So let's think about this graphically. If something does not pass the vertical line test, that's because a single x value results in 2 different y values. Okay, that fails the vertical line test. Right? If I draw a vertical line, it's going to hit both those points right there. Fails vertical line test. So does this fail the vertical line test? Sure, we could plot all the points, but is there a single x that results in 2 different y's? Well, none of my x's repeat, so yes, this is a function. Okay, because there's a unique y for every unique x. Okay, for every x there's only one y. There's no repeat in x's, so it is a function. All right, that's a quick recap for you on domain and range, vertical line test. We talked briefly about a continuous function, so let me quickly add to that. We have continuous and discrete functions. What we just did an example of, which would be plotting a bunch of points, would be considered discrete, whereas like a parabola or y equals x would be a continuous function. Okay, the graph on the previous page is actually called a step function, so that's not continuous nor is it discrete. It's got its own name. It's a step function. All right, so again, that's a recap there for you on domain and range. Not a lot of new stuff for you, so that's why we're pretty vague with what I did here. We'll continue on tomorrow with some properties of functions before we get into our parent graphs and shifting and transformations of graphs. Hope you enjoyed. See you tomorrow.